Hello everyone, I welcome you all to this next video in the Spring Framework lecture series. In the previous video, we had learned about Spring Environment Abstraction and its role with respect to profiles and properties. This video is in continuation of the previous video and we will continue from where we left off. So without wasting any time, let us get started. If you haven't already, please subscribe to the channel, like the video and share the content as much as possible. Internationalization. So, what is internationalization? Internationalization is the process of making something international. Web applications are inherently international, meaning they can be accessed over the internet from anywhere on the planet. However, another important aspect of international applications is support for multiple languages. This is highlighted from the fact that people in different parts of the world speak different languages. The process of internationalization applies to all applications in general, whether it's a GUI application or web application. The difference between them is, in the first case, we will be displaying the messages on a screen, and in the second case, we will transmit them over the wire. Spring support for internationalization. Spring has the message source abstraction which provides internationalization support. The message source interface provides APIs to resolve messages based on different locales. All the messages are keyed on a code and they are resolved based on the locale. For example, this is a message which is represented in English US locale. Here the code is generic error message. The same message in Italian locale is represented like this. The code is always an English language developer defined code. The code are not visible to end users of our application. All such messages are stored in properties file as key value pairs. These files are known as resource bundles. There will be a separate resource bundle for each locale. The key is the code and value is the representation of the message in that particular locale. Let me talk about naming convention of resource files. Resource bundle files follow a specific naming convention corresponding to this format. Here, the base name is any user-defined name. The language code is the two-letter language code and country code is the two-letter country code. For example, the English locale resource bundle with base name messages will have this file name. We can further narrow down the locale by specifying a country code. For United States, the resource bundle file would be this. For Great Britain, the resource bundle file would be this. Here, as you can see, the base name is messages, the language code is EN, that is English, and the country code is US for United States and GB for Great Britain. Internationalization. How does it work? When an application context is loaded, it automatically searches for a message source bean defined in the context. The name of the bean must be message source, M with a small case. We can define a message source bean in our configuration class and it will be automatically loaded and used by the Spring as shown here in this example. Spring provides three default implementations of the message source interface. We can use any one of these implementations while defining our message source bean. Let us have a look at each one of them. The first one is static message source. Static message source is not intended to be used in production systems. Messages are added programmatically and are stored in the hash map. As shown here, I am adding 3 messages and all those 3 messages will be stored in the hash map. The next one is resource bundle message source. Resource bundle message source implementation internally uses Java's resource bundle class. We can define a message source bean like this. We can add as many base names as we want. We can configure the default locale as well. Default locale is used if the matching locale resource bundle is not found. One important note here, the resource bundles are loaded from the class path. The last implementation is reloadable resource bundle message source. We can configure a reloadable resource bundle message source bean the same way as we were doing it for resource bundle message source. The default locale is used if the specified locale is not found. For example, let's say I want to find a message in Japanese language and I am not defining any resource bundle for Japanese locale. In that case, the English language resource bundle file will be used to resolve the message. It doesn't use the Java's resource bundle class and instead uses the Spring resource loader abstraction. As the name suggests, it can reload the resource bundle files based on the timestamp changes without restarting the application. How to use message source bean? Now that we have configured the message source bean, we can dependency inject it into any other bean like this. We can also implement the message source aware interface to get access to the message source bean instance as shown here. Once we have access to the message source object, we can use its API to resolve any messages as shown here. Message arguments. We can use placeholder arguments in the messages as shown here. The integer numbers are the index of the arguments. Once we define the placeholder arguments, we can pass the arguments in our getMessage method call like this. With this, I wrap up the internationalization topic. Next is container extension points. In the context of Spring Framework, container extension points mean the pluggable functionality provided by the Spring Framework to extend its IOC containers functionality. Before I begin, just a casual note, this section is intended towards advanced users of Spring Framework. If you are keen on learning customization aspects of the Spring IOC container, continue being with me on this video. We should never subclass an implementation of the application context interface to plug our custom functionality into Spring IOC container. The Spring Framework has special integration interfaces which expose APIs used by the IOC container to fulfill its requirements. We can customize default functionality by providing our own implementation of such a special integration interface. There are two such special integration interfaces. The first one is customizing beans using bean post processor. If you recall, in one of my previous videos, we learned about Spring IOC container stages as shown here in this diagram. Specifically, the second stage is where the beans are instantiated and most of the Spring's IOC container functionality is located. One of the important phases in a beans lifecycle is the BPP or bean post processor step. This is where Spring allows us to plug our custom functionality into the creation of a bean object. The bean post processor interface has two APIs. Post process before initialization is invoked before the bean is initialized. Post process after initialization is invoked after the bean is initialized. There can be more than one bean post processor processing each bean object. How to register bean post processor beans? An application context automatically detects any beans of type bean post processor and registers them in a list of all such bean post processor beans. To define a custom bean post processor bean, first we need to implement our own bean post processor implementation. Then in the configuration class, we have to define a bean of the same type. You can order multiple bean post processors using the order annotation. The lower the number, the higher the priority. Customizing configuration metadata with a bean factory post processor. To recall, we learned in the previous video that configuration metadata is the recipe for Spring Framework to create bean objects. You can customize the configuration metadata to customize how bean objects are instantiated. By customizing the configuration metadata, you altered the recipe for Spring to create bean objects. Bean Factory Post Processor interface has a single API, Post Process Bean Factory, as shown here in this example. Spring Framework first loads all the configured bean definitions, then instantiates and initializes the bean factory post processor beans, and then invoke the post process bean factory method, as shown here in this animation. How to register bean factory post processor beans? An application context automatically detects any bean of type bean factory post processor. You can register the bean factory post processor by first implementing the custom bean factory post processor class. Then we need to define a bean of the same type in the configuration. This bean will be picked up by Spring and automatically registered in the list of bean factory post processors. You can have multiple implementations of the bean factory post processor and can order them using the order annotation. Spring has good examples of these special integration interfaces use cases. I have summarized them in this table. Using Bean Factory Post Processor, we can customize the recipe for creating objects, and using Bean Post Processor, we can customize the objects. These two APIs provided by the Spring forms a complete circle to cover all needs of developers to plug custom functionality. This brings me to the end of this video. We have come towards the end of the Spring Core lecture series. Our learning journey so far is demonstrated in this animation. The only remaining topic is AOP. We will learn AOP in our next video. As always, thanks for watching. Do subscribe to the channel and share the content as much as possible. I will see you in the next one.